This is your study guide for the quiz that's coming up from 8-1 to 8-2. Make sure that you pick up the paper that goes with it. Question number 1 says, what is the actual length of the meeting room? So when we were practicing scale, we always took the scale and created a proportion. So 3 yards goes with 1 inch. That's the beginning of our proportion, and we are actually looking for length. So we're going to fill in 4 inches. It's going to go on the bottom because that's where the inches are living. I want you to go ahead and pause me. You're going to cross multiply and divide and find out the actual length of the meeting room. All right, did you multiply 3 times 4 and divide by 1? If you did, you'd find that the actual length of the meeting room is 12 yards. All right, number 2 is very similar, although we are going to go one step further and find the area. So to find area, we need the actual length times the actual width. So we're going to start off like we have been starting off. We're going to take this scale and we're going to use 3 yards in real life is 1 inch in the picture. Now, why did I not do the length, do you think? Why do you think I started with the width? You're right. We went ahead and we already figured that out. That was the answer to question number 1. So we already know that this is actually 12 yards. So we really only have to figure out the width. So I want you to pause me. You're going to figure that out. And then to find the area, you're going to take actual length times actual width. All right, so the width was 1.5 inches. The inches are on the bottom. We're going to cross multiply. We're going to divide. And you should have gotten an answer of 4.5 yards. So we have the actual length. We have the actual width. To find the area, we're going to take 12 times 4.5. If you got an answer of 54 square yards, give yourself a star. All right, number 3 says, what is the definition of a scale drawing? Well, I want you to go in your workbook, and you're going to look at page 432, and I want you to write the definition. So pause me while that's happening. So on page 432, you should have seen a definition like this. It's an enlarged or reduced drawing of an object that is proportional to the actual object. This is question number 4. The Weeks family looks on a map because GPS doesn't always work to plan their next vacation. They plan to travel from Beamville to Thompsonville, which are 5.5 inches apart on the map. Then they plan to travel to Thompsonville, from Thompsonville to Brownville, which are 3 1/4 inches apart on the map. And the scale on the map is 1/4 inch is 2 miles. And we want to find the actual distance that the Weeks family will travel by the time they reach Brownville. So I feel like we might have 2 different ways of attacking this. The first thing we're going to do is we're going to figure out the total distance on the map. So from Beamville to Thompsonville is 5.5. Let me change to a pen, not a highlighter. 5.5 inches on the map. And from Thompsonville to Brownville is 3 1/4 inches on the map for a grand total of 8 3/4 inches on the map. Now I feel like there might be 2 ways to attack this. So let's start with our proportions. It says that 2 miles on the map is worth 1/4 of an inch. 2 miles in real life is worth 1/4 of an inch on the map. We're going to place this into our proportion in the denominator because that is where the inches are living. And you can cross multiply and divide to find that answer. But I said I thought there were 2 ways of solving this, and the other one is using our scale factor. So remember, K is our scale factor. If I took 2 divided by, and I'm just going to change, you know me in fractions, they hurt my soul. So if I take 2 divided by 0.25, which is the same as 1/4, I'll get my scale factor of 8. 2 divided by 0.25 is 8. And then all I have to do over here is take my distance on the map times the scale factor. So I'm going to let you do either way. I want you to find your answer that should be the same on both options. And when you're ready for checking, come back. So go ahead and pause me right now. All right. If you did cross multiply and divide, or you simply multiplied your scale factor, either way, the Weeks family is going to go 70 miles. Give yourself a star if you had that right. All right, this is question number 5. It says draw a quadrilateral that has 2 pairs of congruent sides that are 10 and 3, and 2 angles that are both 120. And we're going to look for all of our options. So let's go ahead and write out our options. We could do a square. We could do a rectangle. We could do a parallelogram. We could do a trapezoid. We could do a kite and a rhombus. All right, I think I have them all. So that would take care of the quadrilateral. So let's keep going with these restrictions. It says we need 2 pairs of congruent sides, and congruent, let me write this down here. Congruent means they are equal. So we have 2 pairs of equal sides. Well, a square technically has that, except they're going to be different. 2 are going to be 10 inches and 2 are going to be 3. So I feel like the square is not an option. A trapezoid, I don't think that's going to be an option for us because we're going to have, in a trapezoid, you have a short base and a long base. So let's stick with what we have here. Oh, one more. A rhombus, all the sides are the same, so that one's not going to work. All right. So let's see what we've got going on here. We also need, so we took care of that, 2 angles at 120. So that takes care of our rectangle, because those all have to be 90. So I feel like we have 2 options left. Let's see if we can draw them. A parallelogram is going to look like this. So this would be 3, this would be 10, this would be 3, this would be 10, and this would be 120 degrees, that'd be 120 degrees. I feel like a parallelogram is a good option. All right, let's see if we can make a rhombus work, or I'm sorry, a kite work. So if I draw it like this, where this is 3 and this is 3, and that's 10 and that's 10, that looks good. And then this would be the 120, and this would be the 120. I think a kite will also work. We have two options here. All right, this is question number 6. A playground has two sides that each measure, let me highlight, two sides that are each 35 and two sides that are each 25. And we want to name the quadrilaterals that describe the shape of a playground with those conditions. So I'm going to start you off. You could have a square. You could have a rectangle. You could have a parallelogram. You could have a trapezoid. You could have a rhombus. You could have a kite. All right, looking at all those options, I want you to pause me, eliminate any that can't work for this, and then come up with the answer to question number 6. Okay, so on this quadrilateral, I have two sides that are 35 and two sides that are 25. So did you eliminate a square because all of those sides are the same? Same thing with a rhombus. Did you eliminate a rhombus because all of those sides are the same? Did you eliminate a trapezoid because we have a short base and a long base? I think that might leave us with 3 answers. I think a rectangle, let me change out of a highlighter. I think a rectangle has 2 long and 2 short sides. I think a parallelogram whoops, I don't think I spelled that right. Parallelogram. And I think a kite can have 2 short and 2 long sides. Give yourself a star if you had that one right. All right, question number 7 says, what are all the quadrilaterals that have 2 opposite angles that are congruent? All right, we're going to start with some quadrilaterals. These are my choices. I can have a square. I can have a rectangle. I can have a parallelogram. I can have a trapezoid. I can have a rhombus. I can have a kite. All right, you're going to pause me right now. You are figuring out which have 2 opposite angles. Opposite means they are across from each other. Opposite means they're across, that are equal. Congruent means equal. So pause me while you figure this out and then come back for checking. All right, did you eliminate a square? Because technically, all 4 are congruent. Did you eliminate a rectangle for the same reason? All 4 are congruent. And then the rest of these might be okay. I feel like a parallelogram. Let me draw out a parallelogram. Have 2 opposite angles that are congruent. This one and this one. Or the other 2 are equal to each other, so parallelogram. I feel like a kite's going to work. This one and this one would be equal, so a kite works. I feel like a rhombus would work. Let me try a rhombus. I'm not very good at those. They kind of look like a diamond. Ooh, that doesn't look good. You're going to have to use your imagination. This one and this one are opposite and equal. And this one are opposite and equal, so I feel like a rhombus works. And finally, I think I can make a trapezoid work. feel like this one and this one are opposite and equal. All right, and then I could just draw a generic quadrilateral that doesn't fit into any of these other ones, but I could totally make that work as well. All right, this is the last question. It's number 8. It says draw a quadrilateral with 2 pairs of parallel sides, 2 sides measuring 5, 2 sides measuring 3, and at least 1 angle at 45. Okay, so let me write down my options. Square, rectangle, parallelogram, trapezoid, rhombus, kite. All right, if we have 2 sides at 5 and 2 at 3, a square is not going to work and a rhombus isn't going to work because those all have equal sides. If we have an angle of 45, a rectangle is not going to work because all of those have to be 90. If we need 2 pairs of parallel sides, that eliminates a trapezoid because a trapezoid only has 1 pair of parallel sides. And then a kite, I don't think a kite has any necessarily parallel sides, so that leaves us with a parallelogram. And it would look something like this. 2 sides are 5, 2 sides are 3, top and bottom are parallel, left and right are parallel, and then I've got a 45 right there. All right, make sure you save this study guide. You're going to be able to use it on the quiz.